simple technique, we introduce a little bit more. Yeah, it makes more a gradient in the shape and make it look slightly more interesting, I think. And that is kind of purpose of this post processing, that you sort of apply this kind of sort of simple cheating post processing to make it looks a little bit more appealing. And this was not very complicated, right?
No, let's try and reversing that. Shall we try putting it so that it gets brighter at the edges?
Yeah.
It's not quite so noticeable, but
you can always take you can always just tweak by
just play around with it,
taking 2 or 0.5, and they're always possible to sort of tweak the numbers a little bit.
I think we'll put it back to that because it's noticeable that way.
Yeah.
Yeah, cool.
And so that's one way to do it. There's something else we should do, perhaps, on the post processing. Maybe we should change the colors as well, sort of.
Oh yes, that'd be good. Kaleidoscopes often do that as well, don't they? To vary the color.
Yeah. Let's think a little bit how we do that. Well, one way to do it, which is just pure cheating, and sort of no science at all behind it. Let's see what happens. That is how I operate when I write shaders. I try things and see if I like it. And if I like it, I declare myself being a genius and move on.
And you forget about it if it's horrible, yeah.
And if it doesn't look good, I don't care for it. So this is just randomized coding.
Ooh.
Try and see if that's it looks. But now we see the colors change a little bit over the screen, right?
Yeah, there's definitely color variation, yeah.
The only thing I did was change the saturation of the red and the blue depending on X and Y. It's not really it's nothing brilliant, but we got a little bit this kind of effect of it, right? Let's implement the rotation function that allows us to rotate the coordinate, and that's quite simple to do. So make a function called above post process, and we call it rotate or whatever. It doesn't matter, and it's to return a void. And it takes an in-out parameter, which is a vec2. And p pos. Pos or whatever you want to call it. I said p pos. I meant pos, but it doesn't matter.
I'll change it to pos.
Whatever you're happy with.
Yeah.
And comma and a comma and an angle. Bloom effect, yeah, Dragon Eye. And now we're going to rotate this position. And perhaps I just type how I do
you
it.
carry on, yeah.
So what I do is I compute the cosine, because I'm not sure this is a smart thing to do, but this is just how I usually do it.
Yeah, let's just do it.
Float S. Angle, and then we take pos equal vec2 cosine times p pos dot x plus what is the plus sign?
Yeah, the plus. There
you
go.
pos.y, comma. I have a memory rule for this one as well, which is not like this. What you said was x, y,
y, z, y, yeah.
Yeah. Hard. Post.x. And can we have a plus again?
There you go.
Multiply by pos. Y. No?
There you go.
Yes. And then I'm just going to rotate. What was the function called? Rotate?
Rotate, yeah.
Pos by time.
Wow.
See what happens. I think we can see then that the idea is that colors then rotate around.
That's really like a kaleidoscope now with the colours changing, yeah. It's amazing.
So once again, it's not really broke our back writing these graphics, but it's still pretty. I think it's pretty cool.
Absolutely, yeah. I also like the way that you can experiment. It's very similar to what we were doing with the T4 templates. You write a little bit and then you just kind of mess around and